later. Let's start the tutorial today. So today we will talk about set. I want you to know the definition of set, subset, the cardinality, some basic set operation, and then our exercise will mostly involve defining a suitable simple space and then events. So we will first start with set. Set is just a collection of distinct objects. And there are two ways for you to denote a set. The first one is actually list out all the elements, something like this. The second way is to use a set builder notation. So this notation is saying that the set S contains all the elements that are natural number and they are even. So this is basically just a set of all even natural number. That is the first thing. The second thing I want to talk about is the cardinality of a set. There are a few different situations. The first one is we have a finite set. A finite set is the set that you know exactly how many elements are in that set. For example, if you look at this, how many elements are in this set? 3, right? 1, 2, 3. You can know the specific number. But if I ask you how many elements are in this set, you cannot answer, right? Because we don't know exactly how many elements are in this set. So the first one is called a finite set. Is when the number of objects in the set is finite. For a finite set, the cardinality of a set is exactly equal to the number of objects in the set. For example, if you take the set S equal to 1, 2, 3, then the cardinality of this set would be 3 because you have 3 elements in the set. Move on to the second case when we have infinite. There would be 2 subcases in this. The first one is it is infinite, but it is countable. And the second case is when it is infinite, but it is uncountable. So the common set that are infinite but countable is the set of all natural number, the set of all integer, the set of all rational number, the set of all even number, or the set of all odd number. There are formal way to actually test whether a set is countable or not countable. However, we will not emphasize that in this course. We just need you to know those common sets are infinite but countable set. So which set is infinite but uncountable? Is a set of all real number, or when you have some interval, closed interval, half closed interval, or an open interval. All of them are really common infinite but uncountable set. And you will see that this one, it will relate to discrete random variable that we learn later on. And this one will relate to the continuous random variable that we will learn later on. And there's a bit of explanation behind why it is called countable, but for this one it is uncountable. Because if you look at the set n, is a set of all natural number. This set is called countable because, for example, if I pick one element, I pick number 2, and I ask you, what is the next element? Then you can tell me, right? You can tell me that it has to be 3. If I give you like a number 99, and I ask you, what is the next element? You can tell me it is the number 100. So that's why this set is called countable. Given any number in the set, you can definitely know what is the next element. You know for sure about that. However, if you think about the set of all real number, and I ask you what is the next element after number 2, can you tell? No, right? Because you might think, okay, it might be 2.1, but that is not true because you can definitely have 2.01 that is closer to 2. And then you have 2.001 that is even closer to 2. So you cannot tell what is the next element after the number 2 in the set of all real number. So that's why the set of all real number is uncountable. Does this make sense till this point? Okay, that's good. If you feel confused at any time, you can always type in the chat. The next one I want to talk about is subset. You say that A is the subset of B. Set A is a subset of set B if every element in A is also in B. For example, if you have a set A containing all these shapes, and then B is this set, then is set A subset of B? In order to answer that, you should go through each element in A and you check whether this element is in B or not. So this triangle, is it in B? Yes, it is in B. This star, is it in B? Yes, it is in B. So every element in A is actually an element in B. Therefore, A is the subset of B. However, if you look at this set, is C the subset of B? So I will go through each element in C. Okay, I go to this one. There's a diamond shape. Is it in B? I go through B and I don't find any diamond shape. So this is in C, but it is not in B, right? So at that moment, we know for sure that C is not subset of B. Another remark you should know is that an empty set is subset of every set. No matter if you pick set A or B or C, an empty set is the subset for all of them. And if you want to know why, you can post on Piazza. I will answer about that. The next claim we have is that every set is a subset of itself. Okay? A is a subset of A, B is a subset of B, C is subset of C. Any question till this point? If no, I will move on to the set operators. The first one is intersection. A intersect B would result in a set that contains elements in A and in B. The union would produce a set contains element in A or in B. The minus side, the difference operation, would contain element in A and not in B. The last one is a complement. It would produce for the set of elements not in A. And an example would be, if we take A is 1, 2, B is 2 and 4, A intersect B would contain elements that is in both of the set, right? So I will look through it. Is 1 in B? No. So I don't write it down because I need it to be in both sets. Is 2 in B? Yes. So I will write 2 down. Move on to the union. I want to grab all the distinct elements that I can get from the 2 set. So I would get 1, 2, and 4 because there are 3 distinct elements from 2 set. And then A subtract B would be an element in A and not in B. So 1 is in A and 1 is not in B. So I will write 1 down. 2 is in A and 2 is in B. So I will not write 2 down. So A minus B would give me the set of element 1. Does this make sense? And then you will see that this operation is equivalent to A intersect with B complement. If there is no question, I will let you to work on question 1. Please type in the chat if you have any question. I will let you think maybe 3 minutes for this one. Did anyone got the answer for part 1? Finite countable. How about the simple space? Male, female, binary. Yes, that is for each child, right? And here we have a family that has 3 children. So maybe you want a tuple, right? What would be in this set if this set represents a simple space? For example, yeah, I see something looks good. So the student write out like this, male, 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 which means that the first child is male, the second child is male, and the third child is also male. Or we can have male, male, and female. Male, female, female. Male, female, and male. And then we have female. Like this, right? So I saw a student write 3 to the power of 2. I think you mess up a bit. You mean 2 to the power of 3, like the size of the simple space, right? MMF is the same as MF, and no, it really depends. The thing is, if you want your simple space to take into account the order, then they are not the same, because what they are saying is I have 3 children, right? I have like the child 1, the child 2, and the child 3. If child 2 is female and child 3 is male, it's different from when child 2 is male and 3 is female. But then if you don't care about the order, then you can write something like the simple specs is we have 3 male, 3 female, 2 male, 1 female, 2 female, 1 male, something like that. And it will not take into account the order. So it's like permutation and combination. Yes, that's correct. So the simple spec is really up to you. Sometimes it makes more sense to take into account the order, but then sometimes that would produce too many outcomes. What about the second one? What is the simple space? And then is it finite, infinite, countable or not? Change in the price of a stock during a day. Why do you think it is finite? Tens are the smallest divisible. The thing is, the price, I don't think they will change something like, I mean, like it makes sense for them to change something like this, right? Like plus or like minus, something like that. And then we don't really have any upper bound or lower bound. Yeah, it will be uncountable infinite. I would say the simple space is all real number, even though like realistically some number you might not see, but it's possible. It's just the probability that you see it is really, really low. This one would be uncountably uncountable. And then also infinite. How about the third one? Random selection of real number from the interval. What would be the simple space? And is it infinite, finite, countable or not? S is equal to 2. Remember that this is an interval, so it contains number like 0.55. I think what you were having in mind is something like this. Then there is a set of two elements, 0 and 1. Yes, it is uncountable. And I also see a student write down S consists of X such that X is between 0 and 1. And I will say inclusively because we have the square bracket. And then it's uncountable. Because I said in the beginning of the tutorial, right? When you have like the set of real number or when you have some kind of interval, then they are uncountable. How about the fourth one? Number of animals living in certain forest area. Yes. Let's union with 0 as well. Maybe just in some area, the animal just don't live there. It is set infinite or finite, uncountable or not. Yes. So we don't know how many elements are in this set, so it cannot be finite, right? Technically not finite. It's not finite, definitely. And then it's countable. It's countable because given any number in the set, you can tell me what is the next element after that number. Does this make sense for everyone? I saw someone raise hand. You can like unmute yourself.
Okay. So for number 4, S equals like any natural number. Is that U shape? Is that for union?
Can you
So
say again?
so for number 4,
Yes.
number of animals living in a certain forest area.
Yes.
The sample space equals n, any natural number, and then the symbol after that is union, right?
Yes. Yes. It's
Gotcha.
union. Yeah.
All right. Perfect. Thank you.
Yeah. If no question, I will let you work on question 2. How is it infinite? Because it is n union with like one more number, right? And is n infinite? Yes, n is infinite because you don't know how many number are in this set. Yeah. I will give you maybe 3 or 4 minutes to work on this one, and then I will also pick it up. I saw some answer there. A B complement, C complement, D complement. The thing is, the complement operation work for a set. Is your A, B, C, D a set or is it a CD? Basically here, the simple specs we are looking for is to describe the order in which he visit the CD. For example, like he can visit CDA first, and then he visits CDB, and he visits CDC, and then he visits CDD the last. Or he can do like A first, C second, D third, and then B last, something like that. So what you can write is just a tuple of CD1, CD2, CD3, CD4 to indicate like this is a CD that he visit the first, this is a CD that he visit the second, this is a CD that he visit the third, and this is a CD that he visit last. So our set will contain a tuple of 4 elements such that CD1 can be any CD from A, B, C, and D. And then CD2 can be any CD from A, B, C, and D, exclude CD1. And then CD3 can be any CD, A, B, C, D, exclude CD1 and CD2. Yes, I will explain what a tuple is. Just give me a minute. A, B, C, D, exclude C1, C2, and C3, like this. So this is one possible answer. So I was talking about a tuple. It is like ordered. I wouldn't say pair, but I don't know what other word I can use. For example, like when you toss a coin twice, then you can have the outcome is that the first toss you have head, and the second toss you have head, right? Then this tuple represent that the first toss I have head, and the second toss I have head. And this tuple represent that the first toss I have head, and the second toss I have tail. This tuple represent that the first toss I have tail, and the second toss I have head. And this one would represent the first toss I have tail, and the second toss I also have tail. Does that make more sense to you? Yeah. So here my tuple represent, okay, the first CD I visit is C1, the second CD I visit is C2, the third CD I visit is C3, the fourth CD I visit is C4. And then I will start with C1. C1 can be any CD out of the 4 CD. Maybe I want to visit CDA first. And then what is C2? Then C2 can be B or C or D, right? But it cannot be A because I already visited CDA. So that's why I say C2 can be any CD from A, B, C, D, except the value that I chose for CD1. And then CD3 can be any of these four CD, except the values that I chose for CD1 and CD2. And CD4 will just take the remaining values. Does this make sense? Can someone confirm that you are lost, or does it make sense? Okay, thank you. Next one is I want to write the set A1 such that the salesman visit first CDB. So how would my set look like? You can for sure list out if you want, but I'm telling you that it is a lot if you try to list it out. So maybe you can use a tuple like what I did for the simple space. I want that the CDB to be visited the first. So I will put it in the first position. And I don't know what is the value of other CD. Okay. And now I can pick value for CD2. CD2 can be A, C, or D. Just exclude B because we already visited CDB, right? And then I have CD3 can be A, C, or D, but exclude CD2. And then CD4 can be A, C, or D, but exclude CD2 and CD3. I got a question here. Would we be allowed to only have the possible CD in the curly bracket instead of including the exclusion? Well, you can for sure do that. But the thing is, what are the possible CD for C2? We don't know, right? It depends on what did you pick for C1. Let's say you pick A for C1, then C2 will be B, C, D. Yeah. So that's why I have to write it this way, because the value of C2 depends on the value of C1, and then value of C3 depends on value of C1 and C2. I of course don't want to like give you a bunch of notation that look ugly like this, but this is the most compact way that I can write. Anyone have question about A1? Okay, and then for A2, I want to visit CDB first, and after that visit CDD, which means I know that the first CD that I visit is B, the second CD I visit is D, and I don't know what is the third and fourth that I visit. So I can choose it. CD3 can be A or C, and then CD4 will be A or C, exclude CD3. Any question about this one? If no question, I will leave A3 and A4 for you to write up because we only have 10 minutes left. And then they follow the exactly same idea that I just present. If you want to check your solution, you can always post on Piazza and I will confirm for you. But if there is no question about this one, then I will move on to the next question. Okay, no one say so. I will assume that you understood. I will let you work on question 4. You can either try to list out the elements of the event, or you can use the set builder notation. Anyone got the answer for the event A? S equal to x1, x2. Let's see. I'm not quite sure what you mean by U there. So you have x1, x2 belongs to 1, 2, 3, 4, 5, and 6. And then you say that x1 union x2 equal to 6. Is that what you say? This one, right? Yeah, the thing is, I want to clarify this one, or like this one, they are set operator. What does it mean? It means that the left-hand side and the right-hand side of it has to be a set. For example, you can say set A union set B, but you cannot say like number 1 union number 2. It does not like have the actual meaning. So be careful about that. Those are the set operators. So when you use it, make sure the left-hand side and the right-hand side have to be a set. I see another answer here. I will mark this answer as incorrect for now. The second answer is a set of AB such that AB is in 1 to 6 union N, and then A plus B equal to 6. This makes sense. Instead of this one, you can also write like the set 1, 2, 3, 4, 5, 6. They're equivalent. The interval from 1 to 6, and you only get the natural number. It is the same as this set. So basically, the student is saying that the set A contains of tuples AB such that the value for AB can be get from the set 1, 2, 3, 4, 5, 6, and A plus B has to be equal to 6. So that satisfies the sum of two outcomes is 6. So if you use a set builder notation, this is definitely correct way to write it. If you try to list it out, what you can do is when you throw 2 dice, I would normally write a table like this. So this is the outcome of the first throw. This is the outcome of the second throw. And the intersection would be the sum of the two outcomes. Because here we are caring about the sum, so I write out the sum in the intersection. But if the question involves the product of the two outcomes, you can also write out the product of the two outcomes. Okay. And I'm interested in the sum of two outcomes is 6, which means I'm interested in this part, right? Everything in this diagonal have the sum equal to 6. So it means that I will look at here. This 6 corresponding to the first row is 5 and the second row is 1. So I will write down 5 and 1. This 6 correspond to first row is 4 and second row is 2. So I write down 4 and 2. This is corresponding to first row is 3 and second row is 3. I will write that down. Then I have 2 and 4 and then 1 and 5. Okay. This is another way to write down the set A. You can use this or this. They are both correct. Does this make sense? Okay. Can someone write down what you got for B, C, and D? What do you get for B? Two outcomes are equal. You can either write this way using set builder notation, or this way where you actually list out all the outcomes such that two outcomes are equal. That's almost correct. So I see a student write this down. I have a tuple of A and B such that A equal to B. But if you just write like this, it allows something like 100, 100, right? Because it allows, okay, I see A equal B, and then, yes, we need that restriction. A and B belong to close interval 1 to 6 union with N. So we need two restrictions. The first one is that the value of A and B has to be 1, 2, 3, 4, 5, 6. And then the second condition is that A has to be equal to B. So that is correct. The third one, first outcome is an even integer. What should we write here? A has to be even, right? And since A is the value on the die, it has to be between 1 and 6. So basically A can be 2, 4, and 6. And then B can be any number from 1, 2, 3, 4, 5, and 6. And similarly, we have first outcome is an odd integer. So I can just pick odd value for A, and then B can be anything from 1 to 6. Any question about this one? If not, then it will be the end of our tutorial. Please make sure to attempt question 3 and also try to look at the tutorial worksheet for Wednesday before the tutorial so you have more time to think about it. If there is no question, then it's the end of our tutorial. Okay, I see some questions. C equal to AB in 2, 4, 6. B equal S. Could we say that B is the entire simple space? No, the thing is, B is a number, right? A and B are number. So we wouldn't want to set B equal to some set. But you can say B is an element of the set. B is an element of like 1, 2, 3, 4, 5, 6. Can I say A is even in the set builder notation? Yes, you can say A is even, but then you will still have to mention that AB is from 1 to 6. So BC minus 1, 6. The subset symbol. The C minus, do you mean like the element of? Okay, that is two very different symbols. This one and this one, they are very different symbols. This one is the element of, and this one is subset of. Okay. For example, you see that 1 is element of the set 1, 2, because in this set, you see an element 1. However, you don't say that 1 is subset of 1, 2. Because in order to be a subset, it first have to be a set. So what you can write is that the set of 1 is subset of 1, 2. But 1 is an element of 1, 2. Yeah. Have a good day, everyone. If you have any question, you can post on Piazza